We're now going to take a look at a new operator, which we call the instance of operator. So what we've seen up to this point is that an object of a subclass can be considered an object of a superclass. And we just do this by having a reference variable of the superclass, and it can point to either an object of the subclass type or an object of the superclass type. And then what we just saw in our previous example is that if we use an appropriate cast operator, so if we do this correctly, we can actually have an object of a superclass type be treated as an object of a subclass type. Now, the reference variable that corresponded to it would have to be of the appropriate type, and so if we do that correctly, we're good. But here's a question you might be asking. This may be really confusing because we have a reference variable that can point to several different types. So at any given point in the program, how do we know what type it's currently pointing to? So if I just pick a random spot in my code, does that reference variable point to an object of the superclass, or does it point to an object of the subclass? We need a way to take care of that. And fortunately, we do have a way to do it. We have what's called the instance of operator. Now, this is an operator, it's not a method, which means we're going to have an operand on the left side of it, we're going to have an operand on the right side of it. And instead of giving the format, I think an example is a better way to show this. So let's say we have the following example, p instance of box. So what goes on the left of instance of is going to be some reference variable. What goes on the right of instance of is going to be some class. So what we're doing here is we're asking, at this point, is the reference variable p an instance of the class box? So this is going to be a Boolean operator. It will return true if p does actually point to an object of the box class. Now, if it doesn't, if it points to something else, maybe in this example, p points to an object of the rectangle class, it's going to return false. Let's take a look at an example using our rectangle and box classes. So here we have rectangle and recref being reference variables of type rectangle, and we have box and boxref being reference variables of type box. Now, somewhere along the lines, both rectangle and box would be instantiated, so objects of rectangle and box classes would be stored in rectangle and box respectively. Now, notice the lines here, right here. We have recref pointing to box, so this is going to point to an object of type box. And then we have boxref, which is pointing to the recref reference. And here, since recref is of type rectangle, we have to typecast it to the box class. And this line is perfectly legal. We've already talked about it, but just as a reminder, because recref at this point is pointing to an object of type box, we're allowed to have boxref point to this reference variable, because technically boxref is pointing to a type box. If we had had boxref equals rectangle and try to typecast it, that would be illegal because rectangle is pointing to a type rectangle, and we're trying to have boxref point to that. We're not allowed to do that. So these lines are perfectly legal. Now, the way the instance of operator works is we normally would include it as a condition for an if statement or a for loop or a while loop. So this first if-else statement is checking to see if recref is an instance of the box class. So if so, it's going to print a yes, otherwise it's going to print a no. So if we look here, recref does equal box. So that means it is pointing to an object of type box. So is recref an instance of box? Yes. So this first if-else statement is saying that we're going to print yes. So we're going to execute this line right here. Now, what about the second if-else statement? So here we're checking, is boxref an instance of the rectangle class? Well, we would see that boxref is pointing to recref, but that is pointing to an instance of the box class. So no, boxref is not pointing to an object of the rectangle class, so it's not an instance of the rectangle class. So therefore, it's going to print no. So we're going to go to the else part, and we're going to execute this line here, which is going to print a no. We'll now take a look at another feature in Java, which is what we call abstract methods and abstract classes. An abstract method is a method, but it only has just the heading of the method. There's no body with it. There isn't even any curly braces with it. It is just the heading of the method and nothing else. Now, this heading does have a few other things with it that makes it different from a normal method. it does have the reserved word abstract as one of the modifiers, and it also ends with a semicolon. It almost seems like how we would call a method, except we don't pass any arguments and we do include the word abstract. So let me give you a couple quick examples of what we would consider abstract methods. So we can have something like public void abstract print. So there's no definition here. We know it's still public, it's a void method, but we have the word abstract in here. We can have another one. Here's a public abstract object larger. And then we have two objects here. Now in this case, the objects here are just different types. So we're doing something a little different here just to illustrate that this is an abstract method because we have the word abstract as part of the heading. We have the semicolon and there's no body. And then the last one here is void abstract insert, and then we have a parameter insert item. So here we didn't specify if it's public or private, that's fine, but once again we have the abstract keyword and it ends with a semicolon. There are no curly braces, there are no body associated with this method. Now what about an abstract class? Well, it's a class that's declared with the reserved word abstract in its heading. So it doesn't seem too different from an abstract method. Abstract methods have the word abstract in the heading. An abstract class has the word abstract in its heading as well. Well, there are some facts about abstract classes that we need to be aware of. So an abstract class can contain instance variables, it can contain constructors, the finalizer, and non-abstract methods. So far an abstract class doesn't really seem any different from a normal class. It's just that we have the word abstract in the heading. Now, an abstract class can contain one or more abstract methods. So we can have one abstract method, we can have 20 abstract methods, we can have however many abstract methods we want, but we can have it. Now, if a class does contain an abstract method, then the class has to be declared as abstract. I can't just declare a normal class, have an abstract method in there. If there is an abstract method in the class, I have to include the word abstract in the class heading. Now here's the important part. We cannot instantiate an object of an abstract class. We're not allowed to do that because these abstract methods don't have any definitions associated with them. Now what we can do is we can declare a reference variable of an abstract class type. We're allowed to do that. We're just not allowed to instantiate an object of that class. So I can't create an object of an abstract class and store it in a reference variable. I can create the reference variables, but I cannot do any instantiations. So you might think, then how does this help us? If I can't make objects of the class, what's the purpose of an abstract class? Here's what we can do. We can instantiate an object of the subclass of an abstract class. So we have our abstract class, and I can create a subclass of that abstract class. But here's the kicker. We have to make sure that the subclass gives definitions of all the abstract methods of the superclass. So the abstract class may have abstract methods. The subclass can provide definitions of those abstract methods. And if we do that for all the abstract methods in the superclass, then I can create an object of the subclass and do stuff with it. Here is an example of an abstract class. So there's two things that tell us that. So first of all, we have the word abstract in the class header. So there's public abstract class, my class. And then we see that we have other variables, constructors, methods, all that's fine. But we also have this abstract method right here, public abstract void print. So because we have this abstract method, this class has to be an abstract class. So how do we use these abstract classes? What's the purpose of them? Well, they're used as superclasses. So we're going to create several subclasses that are derived from the abstract class. So we're going to bring in all these variables, methods, and so forth. So all the same context can be derived into all of these different subclasses. And then these abstract classes actually serve as placeholders to store members that are common to all the subclasses. So if I have an abstract method, that gets brought into all these different subclasses, and for each subclass I can define that method however I see fit. So what happens here is they can be used to force subclasses to provide certain methods. So we have to say, okay, this subclass has to have this type of method. Now it may vary by different subclasses. So if I have like 3 subclasses, for example. Maybe this particular method performs a little bit differently in each one, but I'm required to have some definition for each of these subclasses if I want to create objects of them. But what we're going to see in the next lecture is that we will create an abstract class, and we can create these subclasses where each of them provides some additional properties or some unique properties about that particular subclass. And we use the abstract class to make sure that we have all the important things in there.